In any case, I would like to suggest to begin with the presentations. As you know, this is one special meeting in order to celebrate the anniversary of NASE, 50 years of NASE. And
Hello.
also we would like to introduce the new one project of NASE UNESCO. This is Sky Colors, okay? Then our idea is to do both things at the same in this meeting. Then the first speaker is Magda Stavinschi. She is member of NASE from the beginning, and we would like that she give us a short summary of what we are doing with this project for 15 years. Then I suggest that Magda, could you share with us your PowerPoint?
Okay, one moment, please. Thank you. Share. And PowerPoint is this one. Okay, share. I hope to manage it.
Excellent.
I'm speaking as a scientist researcher of the Astronomical Institute of the Romanian Academy, former president of the Commission for Education of IU, and of course, member of NASA. I have to pass, but I don't know how to continue. First of all, it was okay. Moment, please. The
Yes,
technology is
okay.
And
you pass
I like to speak about what's happened before. It was the 90s, almost all over Europe, but especially in the eastern countries. Major transformations were taking place in many areas, one of which, perhaps among the most important, was education. The political transformations were increasingly contributed by advances in information technology and mass media. This is how the school curriculum was increasingly difficult to keep up with the pace of school life. In many schools, astronomy, which had been part of the curriculum for more than a century, disappeared or was swallowed up by other subjects, physics, geography, etc. As the situation was gaining momentum in my country, scientific knowledge was giving way to pseudoscience, I began to take an interest in what was happening internationally in other countries. The IU Education Commission chairman at this time was the late astronomer J. Pasakov. I spoke with him. Several debates were initiated within the Commission on Education Development, which is now Commission C1 on Astronomy Education Development of Division C on Education Outreach and Heritage of the IU, and it was concluded that the simplest and we believe most effective solution was a message to all education ministers that reads as follows. I recall that it was about October 2003, a resolution proposed at the IU General Assembly in Sydney, Australia, by IU Commission 46 on Astronomy Education and Development and passed by the national representatives. Here is what the resolution sent to the Romanian Ministry of Education looks like. It was October 14, 2003. And I have to read because I consider that they are most important ideas of our program. The scientific and mathematical literacy and the workforce trained in science and technology are essential to maintain a healthy population, a sustainable environment, and a prosperous economy in our country. That astronomy, when properly taught, nurtures rational, quantitative thinking and an understanding of the history and nature of science, as distinct from rote learning and pseudoscience. The astronomy has a proven record of attracting young people to an education in science and technology, and on that basis, to careers in space-related and other sciences as well as industry, that the cultural, historical, philosophical, aesthetic values of astronomy help to establish a better understanding between natural sciences and science and the arts and humanities, that nevertheless, in many countries, astronomy is not present in the school curriculum and astronomy teachers are often not adequately trained or supported, but that many scientific education societies and government agencies have produced a variety of well-tested, freely available education and research material in astronomy at all levels of education. So they recommend the national education system include astronomy as an integral part of the school curriculum at both at the elementary and secondary level, either on its own or as part of another science course. The national education systems and national teachers union assist elementary and secondary school teachers to obtain better access to existing and future training resources in astronomy in order to enhance effective teaching and learning in the natural sciences. That the national representatives in the IEU and its Commission 46, that was in this time, calls the attention of their national education system to the resources provided by astronomy, and that members of the Union and all the other astronomers contribute to the training of the new scientifically literate generation by assisting local educators at all levels in convening the excitement of astronomy and of science in general. So it is unusual for a resolution to pass the General Assembly, and we think that this resolution on astronomy education is significant. We hope that you can act on it. It was addressed to our Ministry of Education and all Ministry of Education in all the countries. It was signed by J. Pasakov. As I told you, it was president of this commission in this period, and by me as representative of Romania. So it was a general problem. It was in vain. We organized Olympiads on all levels, local or international, all kinds of events, e.g. Science on Stage in 2000, Science for Humanity, or International Astronomy Day, NASA and UNESCO were interested. If the teachers were not prepared, we even organized a special meeting in 2007, Astronomy Education in Europe. The International Year of Astronomy 2009 was a historical success and reached millions of people around the globe. It is now crucial to cement and build upon its achievements. Who brought together the successful teaching experiences of teachers teaching any of the scientific disciplines, modern methods, lesson plans, example of curricular aids, etc., as well as articles targeting cutting-edge topics and themes of European scientific researches. One of the immediate responses was the creation of a network for astronomy school education, NASE. As you know, it is still directed by Rosa. She was the president of a commission on astronomy education in this interval, and of course by Beatriz García, the next president of the same commission. I'd like to show you the network of astronomy school education. Here is the extension of this network around the world, which proves its usefulness and efficiency in the impeccable way in which it was organized. But the main objective was to educate the new generation of teachers and re-educate the current ones. It means teaching astronomy to teachers and teaching teachers how to teach astronomy. Until now, there were organized more than 400 courses around the world. Only in Romania, we organized from 2014, 12 courses for 483 teachers, about 400,000 students. So it was a great success. I will not reproduce here the exceptional organization and efficiency of these courses, but I would just like to recall those that took place in my country. In Cluj, in Turda, in different cities. You have in Bucharest image of one of the Zoom conference lectures. So, and here it is very interesting to show you the specialty of the teachers who participated. There were not only teachers of astronomy, physics, chemistry, primary, mechanics, chemistry, physics, geography, history, biology, mathematics, physics, physical education, informatics, preschool, English, student. So we were also some teaching material used. There are only some examples. And one of the many diplomas offered to students of NASE courses, they were very useful for them to come back to this kind of courses. Finally, I will mention another idea of the NASE organizers that deserves all the praise, publishing the courses. This is just one of them that I know well because I contributed to it. But it already has several editions and it has been translated in many languages. Here are the authors of this book and the rich table of contents. You could see all these topics which were treated in these courses. And because we are the anniversary hour, all that remains is to wish many years and a big success to the NASE program and the organizers so that the proposed goal is achieved, to educate new generations of astronomy teachers and re-educate the current ones. Big success for all of them.
Thank you. Thank you, Magda, for your presentation. Thank you for this memory about the beginning of NASE. And it was very important for us that you summarize in this way. Thank you. I would like to introduce myself because the next speaker is Rosa, and the idea is that I want to introduce a little bit what is the main points that we decide to present in the NASE UNESCO 2025 this year. Then I want to share my PowerPoint. One moment. Is here. Okay. This is the screen. I share it. Okay. And this is the PowerPoint. As you know, the name of this project this year is Sky Colors, and it is a very simple approach. Of course, it depends on the level of students. We can increase the difficulties of the contents, but the idea is that they understand what is the reason that we observe in the sky so different quantity of colors, okay? Then the idea is that we would like to remember that, of course, the sunlight is a collection, a contains of photons in all the colors of the rainbow, red, orange, yellow, greens, blues, and of course, all of this together appears as a white light. Well, the first activity is a simple activity where you can use you need three mobiles with a cylinder of black color paper. And on the end of these one cylinders, you have a transparent piece of cellophane and red, green, and blue. And when we mix the three colors with the three different mobiles, you obtain the different colors, and the intersection of all of them, it is exactly white. It is a very simple activity that the students can understand much better how the integration of all these colors, we obtain the white color. Well, in any case, when you observe the sky, for instance, in this kind of photos of the moon, you can see that the sky is black. But in our case, for a moment, I would like to try to put this one in a different place. Well, then you know that our sky normally is a blue one. And what is the reason of this? Really, the sunlight passes through the gases of our atmosphere, and the molecules of these gases can scatter the trajectory of the photons. This scattering depends of the wavelength of each one kind of light. Then the blue light scatters more easy than other colors, and we observe that our sky, appears for us like blue. But this is normally in the average of the day. But when you observe it in other moments, then you can observe that the colors are not exactly blue, because the blue is scattering, and then if there are a big one part of atmosphere, then you can observe in the sunset, the colors are not white or blue. The colors are essentially yellow, orange, red, and green. The problem is that red and green, you can see that it is yellow when you mix both of them. Then finally, you observe yellow, orange, and yellow because the result of red and green. Then this is one very special observation that we have in our sunsets. And we can simulate this with a simple activity, like one silicone stick, this small piece of silicone. We put the mobile on the left, for instance. At the beginning, you observe it's a blue color, but after, when you pass more and more distance, then finally we obtain a yellow. Then this is exactly the same situation that we have with our atmosphere. And here is a similar situation with a glass of water with only 1 or 2 drops of milk. And you can see from lateral, you can see that the aspect is blue, but if you observe from the top, the quantity of water is bigger. In this case, you observe a yellow color. This is a simple demonstration in order that they can understand better what is the situation. If the sun is here, then if the light arrives perpendicular to our surface, then you observe the blue one. When is a little bit slope, in this case, the quantity of atmosphere is bigger, and then in this case, we observe the red one, or yellow one, better, not red, yellow. But there is one phenomena that it is the Venus belt. This is a very special phenomena that we observe in the opposite part, where you have the sunset. In the other part, if you look at in this direction, you observe the sunset. But if you are looking to the opposite direction, in this case, you have a blue color, that this is the shadow of our planet. And this is some scattering of a more pink color that pass our atmosphere. Also, there is a very strange phenomenon, very special phenomenon, not strange, very special phenomena, that is the gold light, that there are some authors of films, of movies, that some directors, that they enjoy especially this hour very close to before the sunset, that the color, it looks very, very gold and very attractive, very we have one video that Ricardo prepared, and he will introduce after this, because I would like to finish with some content related to the culture. You know that in NASE, we are very motivated in order to introduce astronomy in the current life of the people. Then, in this case, we propose that the students, they obtain photos of our sky, different colors of our sky. They send to us several photos of the activities, the experiments that they prepare in order to understand these colors. But also we suggest that they try to take information about the popular proverbs and saying that they are relative to the colors of the sky. And then, for instance, I have here a collection of different sentences in different languages that basically is the content, the topic is exactly the same, but it is very, very special in order that to show to the students that really the cultural approach to the colors of the sky is very similar in all the countries. Then this is one short presentation of this new project that we believe it could be simple and very interesting. We are especially motivated in this kind of activities that can be presented in all the countries in the world. Very simple. And also, I think that the best now is to show the video that Ricardo prepared for you. Ricardo, do you want that I pass the video, or do you want to introduce a little bit the video at first?
I introduce. The reddish light at sunset allows photographers to take warm images. It's called the golden hour.
Yeah. It's nice. I love it out here. I like the wheat fields.
Terrence Malick's 1978 film, Days of Heaven, was widely praised for its stunning visuals and even took home the prized Oscar for cinematography. Cinematographers Nestor Almendros and
Sorry. It was not my intention to offer a boycott to your presentation, but
Don't worry. And then, the reddish light at sunset allows photographers to take warm images. It's called the golden hour or magic hour. Some films directors, like Terrence Malick, also films at this time, creating beautiful scenes. The time of the golden hour available depends on the inclination of the sun's path with the horizon. That is, the latitude of the location. In the video, the history takes place in Texas at 30 degrees latitude, but it was filmed in Alberta at 50 degrees latitude to allow double time each day. At the end of the video, Ben Affleck, trying to talk to his daughter, explains what the Venus belt is. The video, Rosa.
Okay, sorry that I did very bad for.
Compart.
Okay, I tried to do it, share. Okay, and now I have here the video. Could you see the video now?
Yes.
Okay.
The sound.
Yeah. It's nice. I love it out here. I like the wheat fields.
Terrence Malick's 1978 film, Days of Heaven, was widely praised for its stunning visuals and even took home the prized Oscar for cinematography. Cinematographers Nestor Almendros and Haskell Wexler used primarily natural light without diffusion. To achieve the look Malick wanted outdoors, they had to shoot the majority of the film at what is known as magic hour, the short period around sunrise and sunset each day when the sun's rays are softer and redder than during the day.
You're in love with him, aren't you?
Thankfully, by shooting in Whiskey Gap, Alberta, the filmmakers were afforded around 40 minutes of the light they needed every day. If they had shot in the Texas Panhandle where the movie is actually set, they would have had half as much of that magical light to work with.
Wait a minute. Stay. Shut up and get back to work.
That red band in the sky right there? You see that blue down below it? That's the Earth's shadow on the atmosphere. Look, you see what I'm talking about? Look for a second. You see it?
this. This is the video. Well, thank you very much, Ricardo. I think it is very beautiful images, and especially with very handsome actors, of course. Well, I would like to continue with our next presentation. It will be a presentation from Solomon Renchin. She is from Mongolia, and she will explain us her experience because she participated in several NASE projects for several years. Solomon,
Hello? Hello, can you hear me?
yeah, very well.
Okay, so could I share my presentation talk?
Yes, of course. You share with us your PowerPoint.
Okay. Hello?
Hello?
So can you see Rosa?
Yes, we can see. Maybe
Okay.
you can put the full screen in your PowerPoint.
Okay.
Okay.
So I put in full screen. Can you see that?
Yeah.
Okay. Thank you so much. First of all, my name is Solomon Renchin. I am professor at National University of Mongolia. So I work with NASE UNESCO project for many years. Today I am very glad to share our activities. And also I would like to congratulate NASE for 15th anniversary. It is a very good opportunity for us to share our activities. So as Mongolia located in central part of in Asia, our location is very unique in a landlocked country with borders with Russia in north, borders with China in south. So it's been 15th anniversary of NASE, and the Mongolian school teachers have participated in many courses organized by NASE. So all courses were very interesting, and our teachers in remote areas, in rural areas, in cities, big cities benefited greatly. So I just wanted to thank NASE. They put all teaching materials available on the NASE website in multiple languages. So anyone from different countries can use this one and use for class teachers. It is very important. So I noticed that the teachers in Mongolia find teaching materials in Mongolian language very usefully. So for us, we attended in many courses organized by NASA. Even we went to Barcelona several times. For example, it was a workshop, a latitude travel in navigate project was developed. It is also Science in Action program in the year of 500th anniversary of journey around the world by Magellan and Elcano. So this book written by jointly Rosa and other groups and included my name, and thank you so much. And actually for myself and I went and participated in this project meeting. It was wonderful and organized very well, and I learned also many things from this organization of this group. So for this, I had presentation NASA and Silk Road. There was a wonderful presentation on NASA. Then NASA education project also allow people to return to the Silk Road and make measurements of latitude for traveling and navigating. It was a good opportunity for us to make exercises for school teachers and the school kids and students. So then I brought my report to this event and presented and shared with other people from NASA. So this Silk Road was a very educational workshop, and still I use these teaching materials and how to make a latitude for traveling and navigating for school teachers and students. Still we use this one. So Silk Road and opened us historical, and also we found many latitude navigation options in how is in our ancient people.
Sorry.
Okay.
You
Okay.
have all the times the same slide. I think that you would like to change it. The same
Yeah.
slide.
So it is changed or not?
No. It's always the same slide.
Oh, no. So this one, can you see that?
We see the first one, the cover.
So this one?
No, only the cover, no more.
Oh, it's interesting. So I have many slides. Maybe I can send this you. Can you share this behalf of me?
Well, don't worry, you continue, and after that, I would like to ask that all the PowerPoints you send to me, and I will put in the website.
Yeah, so we had, I'm very sorry because I had many pictures, photos about my presentation. So Silk Road alone in 2022, I went Barcelona and shared about this activity with my colleagues, and they hear lots of pictures I prepared. In 2023 also, our school teachers went to Barcelona to participate in science action, and shared how measurements about meteorites, small meteorites. It was a very good opportunity for us to share, and our school teachers prepared many materials and brought in Barcelona and shared with other people. So here also many photos, and so I just wanted to, sorry about this, and
khôi phục lại cài đặt, sau đó cài lại cái gì cài được, còn lại
so can you see that?
Yeah, we are looking the photos of your colleagues, I remember.
Yeah, this is okay. So now this. So then we organized also beside the. In my country, we organized several, maybe more than 10 NASE courses. For example, one of these photo we prepare, one of school teachers in remote areas, they organize very well NASE, jointly with our university NASE courses. So we. And also here is another NASE courses with the school teachers. And can you see this photo?
We see the photo now. Yeah.
So it's your photo with our students. Can you see that?
Yeah.
Yeah. This is organized in 2023, after we had attended the astroecology workshop. So immediately after this course also workshop organized by also NASE. After NASE jointly course, Rosa stayed in Mongolia to teach NASA courses in rural and remote area participants. So can you see that, this photo?
Yes.
So in it, this is a NASA activity and also in remote areas. So after teaching NASA course, we also used small telescopes, small Galileo telescopes, and brought for school teachers, and after courses, school teachers had opportunity to observe some planets and before getting night. So it is very good idea. And the school teachers also went and on horses and also on remote areas to share our courses materials and something. Then we had many photos and also letters from school teachers from remote areas. They said it's very good programs and materials and something like this. And they were. So this is, can you see that, Rosa, astroecology, this photo?
Yes, we saw, but it could be a good idea if you pass the slides, because you fix only one slide. You pass the next one.
Yeah, I pass next one. I pass next one, and
okay.
There and also we also organized during NASA courses. We also one of activity was astroecology course. So astroecology course was in 2023, and also we're going to organize astroecology course in September 2025. So I just wanted to share about this activity with NASA groups and teachers, so that they can come Mongolia, can visit Mongolia. We can together to organize NASA activities in Mongolia. It is just my one of my NASA possible plans, I think. So can you see that, this photo?
Well, we are seeing some photos, but you don't change them.
Okay, so it's very pity, and I cannot short. So.
Okay, don't worry. You send to me the PowerPoint, and I will put them in the website.
So then it is. So I just wanted to share at least last time again. I will start to share.
Now,
last photos, and okay, thank you. I will
thank you very much.
So this one, it was my last, almost one of my. Can you see that, some camels, and so it is my last slide. So that I wanted to share about activity, possible NASA activity in Mongolia in September 2025, in coming September, so that we have a beautiful desert area, and there are also now NASA school teachers. They also. Then we wanted to jointly organize NASA training workshop, and after that, during this we can plant tree under stargazing in activity. So that I wanted to share about this in September. So I'm very sorry about this. I couldn't share properly my slides, but Rosa, can you distribute it later for our colleagues? And
yes, send to me, and I will put in the website, and I send you an email with all the PowerPoints there. Okay, I give you the link where you can see all the PowerPoints and all the participants.
Okay.
No problem.
Okay, thank you so much. Happy 15th anniversary also, NASE.
Thank you for your participation. For NASE, it is very important that we have active members in all the countries in the world. And in Mongolia, we know that really NASE is very active. We are very happy with this. Thank you, Solomon. Thank you.
Thank you. Okay.
Well, in this case, we are a little bit early that our schedule. I am really surprised, but we are a little bit early. But I don't know if Beatriz in this moment is in one course, and then we have to wait a little bit that she arrived. Then I would like to invite to all of you, it is possible to turn on your cameras and to take a photo of a group photo with all of you. If you open your cameras, okay? And US mail, of course. Okay, thank you very much. Thank you, perfect. From Togo, we didn't see you. Setsa. Well, there are some people that we don't see in this moment. Hello, Jibaji. Hello, Ivo, Nindita. It is very nice to look all of you. Alexander, hello. It's a new one country that begin to work with us. And Medar, thank you very much to participating. Feng Chong, it is the person from the planetarium in Beijing. Well, I take a picture of all of you, okay? And I pass the next one screen. Bravo, I see Hakim, Lilith, hello, Fatime, Paula, Trang, hello, from Vietnam.
Hi everyone. Yeah.
Thank you, thank you. Perfect, perfect. Hello. She was my guide in Togo. I remember very well the special visit. And to all of you, thank you very much for participating in this meeting. And I don't know if Beatriz is ready or not. Not yet, maybe. I don't know. Maybe we can continue with the next one speaker, because we are in this moment, we had to wait 15 minutes for the next one speaker, is Beatriz. Then I suggest that the next speaker that will be the Professor Zhu from China. And I asked for Feng Song that introduce her in the presentation. I don't know if I lost. Yeah, I am here.
Yeah. Hello.
Hello,
Can you
Feng.
hear me?
Yes, very well. But
Hello, everyone.
Professor Su. What is Su?
Where is Zhu? Let me see.
I don't see her. Okay, you can introduce her.
Okay.
Hello, Rosa. Can I ask a question, Rosa?
Okay.
Hello. I'm
Hello.
Feng Chong from Beijing Planetarium. Beijing Planetarium is one of the most famous astronomy education and popularization organization in China, and also the Connect organization of NASE in China. Today, I'm very honored to introduce a star teacher, Ms. Zhu, to all of you. Ms. Zhu is the science teacher of Zhongguancun No. 2 Primary School in Beijing Haidian District. The Nebula Society is an astronomy club at this school. It has close to 100 members from different grades and has been doing all kinds of hands-on science projects and fun astronomy activities. The club has joined NASE activities for the past 2 years. This year, they are really looking forward to being part of the International Day of Light celebration. Now it's time to Teacher Zhu. Let's welcome.
Thank you.
各位老师，大家好，我是中国北京海淀区中关村2小的天文老师朱格雅。特别的开心能参加今天的大会，然后我们也很期待这次的大会。接到了这次大会的这个主题之后，叫做天空的颜色，我们觉得这个活动非常的有意思，然后呢就迅速的组织了一个骨干小队，我们小队的名字呢就叫做天空彩绘师，所以呢我就邀请了我们这次的骨干队员都来参加我们这次会议的开幕式。下面就请我们的骨干队员自我介绍一下。
Thank you, Miss Zhu. We are a group of third graders. My name is Dong Zhou, the team lead. I organize activities, encourage teamwork, and help members explore creative solutions.
Hello, everyone. I'm Yao Lang. I'm 9 years old. I like to play football. Hello, I'm
one of the publicity team leaders of the Sky Painter. My name is Liu Hongyi. Hello everyone, my name is Doris and I'm 9 years old today. Hello everyone, I'm He Luyi. I'm the teach director. I'm 8 years old. Together, we're committed to making this project a huge success by inspiring curiosity about astronomy and the science behind the colors of the sky. Now, let me walk you through our journey so far. Our timeline is divided into 3 phases. Phase 1 lasts from March the 8th to the 19th. So far, we've achieved exciting milestones. On March the 19th, we hosted a live stream to kick off the project. We introduced the theme of the Sky Colors project and the history of the International Day of Light. We shared background knowledge on light phenomena through 3 experiments. These are some photos of the live stream, which was a big success. Over 200 participants, mostly students of our school, joined our live stream where they learn about the nature of light as well as photography basics. Now let's watch videos of the 3 key activities being performed. Activity 1, dispersion in the water. Activity 2, dispersion in silicon. Hello, I'm from the Junior Circle that can represent different sky colors. Let's gather materials and begin. First, we need a flashlight and silicone stick. Now, press the flashlight tackling against the base of the cylindrical stick and turn it off. Let's go down. See how the stick bears her right leg through the top near the bottom. Yellow is in the middle. Red push higher. Now, if we move the flashlight further away, the color fades. Look at this picture. The left shows a sunset, and the right is our experiment. Both display the same blue, yellow, red symptoms. Our study actually mirrors the sunset sky. Why does it happen? Then we have a tiny picture on the horizon. Its light takes a super long path through the air. When the sky is still blue, only red plays to your eyes. Chemicals still contact dust-like region, kind of like how aerosols in the air act. They scatter away green and even yellow light, leaving the red. That's why we get those super red sunsets. But then, let's experiment. Here comes the flashlight. How does the color change? What other materials could you use to explore this? That's all I have to say. Thank you.
Activity 3. Addition of colors.
Well, I am your second knowledge. Today I'm doing a funny experiment with you. If we mix the green colors, we see one light, like the sun. If we remove the blue light, the mixture of green and red light appears yellow, which is what happens at the sunset. Why sunset appears yellow? Because when the sun moves slowly in the sky, its light passes through 4 layers of the atmosphere. Almost all the blue scatters, and the light has switches of its only red, yellow, orange, and green. The green light is mixed with red light, leaving yellow sunset. If the green light disappears, it appears orange or either red. In the end, I also mixed a cube with yellow light. Can you tell me what will happen if I mix yellow with red, blue, and green?
In phase 2, that is March the 20th to June the 30th, workshops on light science and photography techniques will be provided to classes in grade 1 and grade 2. These are the photos taken in the workshops that have already been provided. You can see that the students were so eager to win awards that they scrambled to answer questions during the workshop. And at the same time, we are collecting photos and videos from participants. Let's welcome Yao to introduce this part to you. Hello everyone, I'm Yao, the various mentor responsible for guiding this Sky Painter Photography Challenge. Together, we'll pick up our phones or cameras, step into nature, and capture the breathtaking beauty of the sky. This is a creative feast where we'll use light and shadow to document the grandeur and wonder of the nature world. Event duration. The challenge runs from March 22nd to June 30th, giving everyone plenty of time to discover and photograph the most stunning sky moments. Whether it's morning glow, sunset, rainbow, solar halo, or lunar halo, all can be your creative subjects. Participation is simple. 1. Scan the QR code on the poster to fill in your details, including your name, contact information, school, and class. 2. When submitting your work, you can choose either photos or videos taken with a mobile phone or camera. When naming your work, make sure it reflects the subject's or scene, such as flaming sunset or rainbow bridge. 4. Important reminder. Include the shooting time, location, and device, such as phone model, ISO, focal length. And here's the exciting part. Outstanding photographers will receive gifts from the Nebula Society, and their work may be featured in a photo album, preserving these memories forever. Thank you all, and let's paint the sky together with our lenses.
That's all for our sharing today, and we'd absolutely love these activities. And it had left us wonderful memories. That thanks you all very much.
Thank you very much to our participants from China, and especially I would like to say thank you to the students that participate in this presentation, because they are very young students and they speak very well English, and I think it is not so easy when they have a different alphabet, a different structure of grammar and all of this. Then excellent contribution, thank you very much, and congratulations to Zhu for all the students that he is involving every year. Thank you very much. Well, the next speaker, I don't know if Beatriz is here. Ricardo, do you know? Not yet?
来一块集体说一下拜拜吧，咱们说完了。
Se conectó, pero luego se desconectó.
Then maybe we continue with the next.
Bye-bye.
Bye-bye. Maybe we can invite to Margarita Metaxa for the next presentation, and we try to introduce Beatriz when he can be here. Margarita, are you ready?
Can you hear me?
Yes.
Okay, I will start. One moment to share my, one moment, please. I want to share my screen. Can you see it?
Yes.
Okay, let me put it on presentation view.
Yes.
Okay. Can you see my presentation? Can you hear my voice?
Yes, yes,
Oh,
yes.
all of this.
Okay. So happy anniversary, NASE.
Thank you,
very
Margarita.
much, Rosa, Beatriz, Ricardo, for all the inspiring projects and for our collaboration. In this project, we are talking about sky colors, but we can't, of course, forget that NASE is an astronomy association, teaches astronomy, so how could sky colors in other planets miss? I start with this impressive simulation. Hope you can see it. So I start with this impressive simulation of sunsets in different colors, in different worlds, full of different colors. And as you know, I'm going to talk about multicolored skies, about skies on different planets. The solar system planets are an array of colors that with vibrant yellows, reds, and blues to dark grays and murky browns. But why is this? What colors are the planets? Why are all have different colors, and what causes this difference? This is a simple question, but it seems simple, and it doesn't have a really simple answer. Usually this is the way that astronomy goes on with the different questions. That's because it depends whether we are talking about the color of a planet as it appears when viewed from a telescope, or the color you would see if you were standing on the surface of the planet. Before we get into this, we need to set the rules of what we're talking about. So we are talking about the colors that the skies of the planets have. Let's put some rules on that and start talking. An atmosphere is a layer or several layers of gas that surrounds a celestial body. Usually, atmospheres are associated with stars, most of the planets, although other celestial bodies can have them, like comets, usually temporary. An atmosphere can be acquired in different ways. It can be accreted onto a celestial body by gravitational attraction, or it can be released from a celestial body itself in a process referred to as outgassing. Whether or not a celestial body retains its atmosphere depends on the body's mass and the temperature of the atmosphere. Generally speaking, the more mass the body has and the cooler the atmosphere is, the better chance we have, the planet has to have an atmosphere. Our experience here on Earth tells us that the color of the sky is somewhat related to the sunlight, as our excellent young colleagues from China showed us. The dominant effect due to which we have blue morning skies and red sunsets is called Rayleigh scattering, more or less mentioned previously. Rayleigh scattering has a strong dependence on wavelength. As you can see here, the intensity is inverse, the fourth power of the wavelength, and more or less have no angular dependence, not but to the angle of 0. What is important to realize is that Rayleigh scattering refers to elastic scattering from the, one moment. You can hear me? Can you hear me? Okay.
Yeah.
Okay, refers to elastic scattering of light from atomic and molecular particles whose diameter is less than about 1/10 of the wavelength of the incident light. And please have this in mind for the other discussion we are going to have. Another very interesting scattering that also happens here on Earth is called Mie scattering. Misscattering occurs when the size of the particle is of the order of the incident wavelength. Now we have particles which are quite similar with the wavelength. And misscattering works only for spherical particles such as cloud droplets. This type of scattering is responsible for the white appearance of clouds, and misscattering is not strongly wavelength dependent and produces the almost white glare around the sun when a lot of particulate material is present in the air. But pay attention, misscattering has a strong angular dependency of the scatter intensity, especially for smaller particles. This is what causes the blinding glare of car headlights when the car is driving in the fog. Have these two phenomena on mind. One moment, please. Let's have these two phenomena on mind, and let's start and explore what's happening on Mercury's atmosphere. Well, on Mercury, let's say on Mercury. Mercury is the smallest planet in our solar system and the one closest to the sun. Its gravity is weaker than large planets, so it cannot hold on a substantial atmosphere, but it holds an exosphere. Mercury's exosphere is composed mostly of oxygen, sodium, hydrogen, helium, and potassium. Perfect conditions for a planet with jet black sky. The day on Mercury will be black, dotted with stars, but the sun, which would be almost 3 times as big as it appears on Earth, and would dominate the day. The night sky would also be pitch black, but with more stars than we can see here on Earth. We have some photos from probes that have been flown by and orbited Mercury, like Mariner 3, Messenger, and Bepi Colombo. We are still going to have some more images from Bepi Colombo, but be sure that on Mercury, the sky would look like the moon. The next planet we are going to talk about is Venus. The atmosphere of Venus is a very dense layer. Of gases. Venus' atmosphere is composed mainly by carbon dioxide and a little bit nitrogen, with other chemical compounds present only in trace. Through studies of the present cloud structure and geology of the surface, combined with the fact that the luminosity of the sun has increased by 25% since around 3.8 billion years ago, it is thought that the early environment of Venus was more like than that of Earth, with liquid water on the surface. At some point in the evolution of Venus, a runaway greenhouse effect occurred, leading to the current greenhouse-dominated atmosphere. The timing of this transition maybe should be 4 billion years ago. The runaway greenhouse effect may have been caused by the evaporation of the surface water and the rise of the levels of greenhouse houses that followed. This received a great deal of attention from those studying climate change on Earth. As we said, Venus has a very thick atmosphere and has a lot of large particles suspended in it that differ according to height, of course, from the surface. On Venus, both misscattering and Rayleigh scattering occur, depending the layer we refer. These dusty clouds interact with the longer wavelengths of light and send them towards the ground for our eyes. Therefore, for most of the day, the Venusian sky would look yellow for a human eye, which was also confirmed by color photos transmitted by the Venera probes early in 1980. The downs in Venus must be blood red, not this color. Then we have Earth. The sky, the colors of the Earth sky were very nice explained by our young colleagues from China. So I will pass through, and I'll come on Mars. On Mars, we have an atmosphere mostly by carbon dioxide. You can see here the composition, and some argon, nitrogen, traces of oxygen, carbon monoxide, water, methane, and other gases, but plus a lot of dust. The molecules of carbon dioxide are more or less the dimension of the molecules in our Earth's atmosphere. So, if we should make a prediction, the atmosphere of Mars should be during the day blue, like the sky here on Earth. But we have so many nice views and photos from various probes. Here you see from the Perseverance mission. And on these skies, from these photos we can also have lot of information. These images help scientists determine not only how high in the atmosphere the Martian dust extends, but allow them to look for dust or ice clouds and have some perception about the geological history of Mars. Definitely the sky colors in Mars are not blue. They are something yellow, orange, and these colors dominate the morning sky of Mars. But why does this happen? This happens because Mars' atmosphere is very thin, as you can see on this image. It's very thin, so there aren't as many air molecules for the photons to bump into. This means Rayleigh scattering does not have much effect on the color of the day sky. On the other hand, frequent dust storms whip up particles that have a fairly wide distribution of size and spread this dust to the atmosphere of Mars. This dust scatters red light and blocks much of the sunlight. It scatters red light much better than blue one. Additionally, the reddish iron oxide in the dust particles actually absorbs blue light. This creates the distinctive dim orange or yellow hue of the Martian sky, for which we refer as a butterscotch sky. New data and analysis of observation give us evidence of iron oxides that contain water. This is very important because these watery iron oxides were combined early in the geological history of Mars, and from this signature we can get even more information. But on the other hand, when we come to the sunsets, definitely the blue colors dominate. The blue sunsets in Mars is a very complex process and is not fully yet understood. Most experts believe that is due to misscattering. Misscattering tends to angle the light forward, in particular a blue glow around the sun direction. The forward angling of the light also accounts for the unique fan-shaped halo above the sun. As you can see on this photo, although focused in front of the sun, we have these blue colors a little bit, well, much further. Still, the yellow-orange hue is present. On the other hand, if some humans in the future were going to climb Martian mountains, and Martian mountains are really high, at least 9 to 10 kilometers high, they will see absolutely space-like black skies because of the so thin atmosphere that Mars has, as we have already said. And then, of course, after the sunset, the night comes. And when the night comes, future Martian explorers can stave off the homesickness with the sight of familiar constellations like this of Cassiopeia you can see here. So more or no, the Martian sky is quite interesting and beautiful, and of course the same physics laws dominate all the phenomenon that occurs there. Now we come to Jupiter. Jupiter is a giant, but is a giant which is made from gases. And here it starts to get really tough, but also interesting. It's hard to even define what we mean to be on Jupiter and to look to the atmosphere. Because, as I told you, it's a gas giant planet, and we don't really know what's beneath the thick atmosphere that we can see from space. We think, and our models say, that at some point there must be something solid there, but we don't know exactly the distances and all the composition, so to say exactly what color the sky of the Jupiter would like. Let's just pick a spot not too deep inside the Jupiter for the moment. Perhaps, surprisingly, the sky would probably be blue, thanks to the same Rayleigh scattering that gives Earth the blue. But it would be pale on Jupiter, since it's 5 times further than the Earth, so it actually receives a lot less light. This in turn would probably make the sky a paler blue if the spot we were standing on was much deeper inside the planet. The sky would get redder and redder as the scattering stops the blue light, making it that deep, and it would also get darker and darker as less light makes it down that far. We have no probes from inside the planet to imagine ourselves stood on, and there is some disagreement about the color of the sky would look if you were below the Saturnian clouds. One option is that it would indeed look blue, again, thanks to Rayleigh scattering we've always discussed. The other possibility is that the sky would indeed look yellow just as the planet does from the outside. This would be caused by the high abundance of ammonia crystals in the upper atmosphere of Saturn. Fortunately, in the case of Saturn, we have some Cassini images that shows the sky in the upper atmosphere is blue, but the predominant color of its color deck suggests that it may be yellowish further down. Also, observations from the spacecraft show that seasonal smoke develops in Saturn's southern hemisphere as its perihelion due to its axial tilt. This could cause the sky to become yellowish at some times. As the northern hemisphere is pointing towards the sun only at aphelion, the sky there would likely remain blue. The rings of Saturn are almost certainly visible from the upper reaches of its atmosphere. The rings are so thin that from a position on Saturn's equator, they would be almost invisible. However, from anywhere else on the planet, they could be seen as a spectacular arc stretching across half the celestial hemisphere. It seems that Saturn's sky is not at all boring. Then we come to the two blue brothers, Uranus and Neptune. These ice-eyed giants of our solar system are both fairly similar. Both have a blue sky, but the shades of blue are different. Both of these planets have atmospheres that are composed primarily of hydrogen. This will scatter blue light more than red light, giving us a blue sky. However, Uranus also has a good amount of methane in its upper atmosphere, which scatters both blue light and green light quite often, leading to a more cyan color. Finally, we arrived at Pluto. New Horizons spacecraft gave us the first good look of Pluto in 2015, which was adjusted according to human eyes finally and at 2018. And this image revealed Pluto to be a model of dark and light grays and browns. Subsequent analysis of the imagery have led scientists to believe that it is covered on ice made of nitrogen, methane, and carbon monoxide, plus some organic material. Additionally, New Horizon gave us amazing photos of a blue haze. Scientists believe that this haze is a photochemical smog from the sunlight on methane or the molecules producing a complex mixture of hydrocarbons. Because of their size scatter the sunlight to make thus blue haze. So now I came to the end of this short journey in the atmospheres of the planets of our solar system. I end my presentation again with this very nice simulation, and I hope that maybe this presentation can give us some thoughts of different experiments that we can conduct here with NASA concerning the colors of the atmospheres in on the planets of our solar system. Thank you. Rosa, I didn't hear.
I said that thank you very much for your interesting presentation. And I think it is very, very positive that open us many questions about to know more and more. And this is essential, the point of view of the scientist. Then thank you very much, Margarita.
Sorry, Rosa, but I didn't hear anything of what you said.
Now, I think that now my macro is active. Before it wasn't, but now
okay.
I think that, okay? Well, in any case, thank you very much. Very interesting. And I would like to continue with the next one speaker is Beatriz García, that we have to change a little bit the order because it was not connected when I tried before. Okay.
Yes.
Beatriz, when you want.
Yes, thank you. Thank you very much. I'm sorry because I am now in a northern province in Argentina, in Salta, giving a course. It's not NASE, but it's a course for about astrotourism. So we are, trying to connect both landscapes, the Earth and the sky. So my contribution today is mainly to vindicate the proposal of NASE. NASE along the 15 years, happy birthday, NASE, with a few things to produce great results. And these few things can be, for example, this tape and this glue and this cutter and eventually a photocopy. And the photocopy we will use today is to see the light. So the things connected with the light started at the very age, at the young people at the school work a lot with this kind of resources. These are my favorite things to explain why the yellow is not a primary color, but it's very important thing because with this kind of very simple productions, you can show, for example, two main characteristics of the light, like absorption and reflection. And also you can explain how the eye work, because here you can see separate the colors, and if you move this disc, you will see the color mixed. I hope you can see the color mixed. This is a violet, blue and red. The eye cannot separate the colors when the colors are in movement, and because of this is good to show a part of the colors we know and we use in the normal life, but also we can explain that the light can be analyzed in a different way and is much better than to use pigments. The light is the real source of the colors, and in this sense you can use another devices, for example a diffraction grating, like this one is a diffraction. I can use this to show and to see the colors. The problem is not everybody can access to this thing, this kind of technological creations, and all the people know that we can see in the nature different things of a spectra. We can have the continuous, the emission lines and absorption lines, and the stars are working showing this kind of things. And also in the colors, we have just a few information about the nature and about the electromagnetic radiation. The visible region of the spectrum is a small part of the whole energy produced by the stars. And you can see the visible because you born
I think that we don't have a good connection with Beatriz. The image is blocked and the voice also.
Hello?
Yeah, now
Now
yes.
you can see me?
Okay, now yeah. Yes, it's blocked.
I will use this other, can you see me in full screen?
Yeah.
Okay, well, I will show you some slides and the old-fashioned slides. We have the continuum spectrum. This is a small part of a big distribution of energies. And the thing is that if we can see different regions of energy, we can know much more about the functioning of the stars, the galaxies, and the universe. To do that, we need to use a special instrument. And there are a lot of different proposals. I will show you one produced by CERN Institute. Is this small device? It's called an spectrograph. This spectrograph is used in cell phones. Was created by the CERN scientists, the scientists. But NASE has another proposal. Is this one. You know very well the NASE spectrograph. We love it. It's more than a spectrograph, it's a spectrometer because you can measure the wavelengths. You can measure the wavelengths, and in this way, you can know in which wavelength the colors appear. The NASE spectrography was created by Ricardo Moreno, who is here as host, and you don't need a lot of things. You just need a little piece, very little piece of CD or DVD. You put the piece of DVD in the window, you cut the slit, the light enters through the slit, and finally you produce this beautiful spectrometer with which you can see a lot of really nice things. I will try to show you some of them. This is my table, my work table for today. And we produce the spectrometer, is here. And through the window, you can see how the light can be divided into, wait a minute, here, into the colors. What a beautiful thing. Because if we know where we can use this, and we can use this directly, look in the stars, we can know a lot of things, with things about everything. Look at this image, for example. This is better, the light. The astronomical objects emit in different wavelengths, and the information we obtain from different regions of energy in the electromagnetic spectrums transmit us information about things we can see and we cannot see. This is the power of the study of the light. This is the power of the study of the colors into that thing we call electromagnetic radiation. NASE, along 15 years, produced thousands of these small devices. There are millions of children and teachers and parents using these devices at home, at school, at the street. And this was thanks to you, every one of you, teaching how to see the colors in the light, how to produce very, very simple instruments, and how to transmit this knowledge to the others. NASE is a kind of chain of knowledge. We transmit these concepts, you accept and introduce in your brain these concepts, and NASE in this way is now in 4 continents, more than 70 countries, with more than 1,000 volunteers. That is my contribution for NASE program. Thank you very much.
Thank you very much, Beatriz. I think that it is very, very motivating for us that the results of our materials and our courses will be extended in the world for many countries. Thank you very much. And I would like to connect this with the next one presentation. All of you know that last year we have one project about a catalog, a NASE catalog for schools, because we thought that it could be a good idea to consider the possibility to prepare one catalog for schools without telescope, because the majority of our schools don't have it. And then, you know that last year we invite to all the participants to take an observation, to take a drawing, or to make a photo of one diffuse object, and after to send to us. And also they send to us a voting about the different objects that teachers and students believe that should be interesting, that normally the young people in the world, they know a little bit about these objects. This was collected for all of us, and we prepare a summarize of this. We prepare the NASE General Catalog, NGC catalog. Of course, this is a joke, but well, in any case, we thought it was a very nice joke for the teachers and for students. And now Ricardo will present us these results, this booklet, this catalog. And after that, I would like to invite to several people, one for each one, different continents, and we have 4 continents here, them in order to discuss a little bit about this proposal, okay? Then I suggest that Ricardo begins with the PowerPoint, and after that we open our connections to all the people interested in to discuss a little bit. I personally invite one person for each one country, for each one continent, sorry. And well, the idea is that they give their opinion, and after to open to all the participants in the session. Okay, then Ricardo, when you want to begin, it's okay.
Okay. Veis la presentación, ¿no? Can you see the presentation? Okay.
Yes.
Pues 2024 NASE UNESCO project promote sky observation with the naked eye, binoculars, or small telescopes. NASE selected some objects from the Messier catalog and added several objects in the southern hemisphere that weren't included in the Messier catalog. The NASE proposal suggested a list, but invited students to observe any interesting selected object, even if it wasn't on the list. In addition, a vote was held among the teachers and students involved in the project to select the most popular objects, those we would like to see in our own catalog. The project was a success, and 560 submissions were received from many countries. Since most observations were made with the naked eye or binoculars, the voting winners were objects visible without telescope. A volume was published with the 16 most popular objects under the title NASE General Catalog NGC for No Telescope School. NASE astronomers find this title suggestive because it reminds the well-known NGC catalog. The NASE catalog includes 16 diffuse objects for nebula, for galaxies, for open star clusters, and 4 globular clusters. Some are visible in the northern hemispheres, others in the southern hemisphere, and some are close to the equator and are visible from both hemispheres. In the publication, each object is in a double page. It includes the name of the photograph, a photograph, visual magnitude, distance, and position of the object. There is also a description of the object and some historical notes. A sky map is included with Norway constellation to help you locate the object and know where to look. In some cases, Okay. In some cases, paths from known star have been added to find the object. In the final page, there are some observation tips. For example, how to choose a good place and date, how to observe with binoculars, resting your elbows on the back of a chair, etc. Finally, the publication can be downloaded from the NASE website. Thank you very much.
Rosa, we can't hear.
Thank you, Margarita. Thank you. Then I said that thank you to Ricardo for this presentation. I think it's a summary, very short summary of our catalog. And I would like to introduce the people that I connected, one person for each one continent, in order that they give their point of view and their opinion about why they choose these objects, okay? Then I would like to invite from Africa to Medar, or also I saw Perfect is here from Togo. I don't know if they are. Hello, Medar.
Hello, Rosa.
Also, I would like to invite from America, Ligia Arenas. I don't see now. Before I saw Ligia.
I am here.
Hello, hello, Ligia. Also, from Asia, I would like to invite Fatime. Fatime, I want to say to Fatime, thank you very much, because she's from Iran, and this country have a special work promoting astronomy in the schools, and especially last year she sent to us hundred of reports participating, okay? And from Europe, I invite Ivo Joaquin. I saw him. Here, okay. Then, well, my idea is to give them some minutes in order that they explain to us why they believe that it is interesting that students observe some diffuse objects, and of course they define the objects that they propose for the catalog, and we accept that, okay? I don't know who would like to be the first one.
Thank you very much, Rosa. I can begin, no problem.
Thank you.
Hello, everybody. I am Kofi Ador from Togo. I am the president of NASE team in Togo. I am very excited to be with you today in this incredible meeting to talk about NASE catalog. I have my co-worker Perfect here. I'll give her the floor to talk about how we support this project. Thank you. Perfect, you have the floor. You can talk.
Maybe, I don't know, Ligia, Ivo, Fatime.
Thank you. Thank you very much.
Hello, Perfect.
Hello.
Hello. Your opinion about
Thank you very much.
About the objects that you present to us. I think it was Nebula, the Nebula of Orion that you suggest to us. I don't know.
Okay. I'm Perfect Gisova from Togo. I'm a member of NASE Togo team.
I'm very happy to be with you in this important day. So first of all, I want to congratulate NASE team, all the NASE team, to his interest they have shown in us. So today I want to talk about something fascinating, the Orion Nebula. It is a beautiful and bright nebula that can be seen even without a telescope. And I believe it should be included in the NASE catalog to help students learn more about astronomy. In my point of view, I see that it's great for students because it is easy to see. You don't need a telescope, just your eyes or binoculars. It is a great example of how stars are formed, which makes it exciting for young learners. It helps students feel more connected to space, even if they don't have access to advanced equipments. So the NASE catalog, it means also to help students discover astronomy in a simple and accessible way. I think that the Orion Nebula is perfect for this because it is one of the brightest nebula, so anyone can observe it, even from a city. Many schools don't have telescope, but this nebula can still be seen without one. So it is a great way to introduce students to the wonder of space without complicated tools.
I agree that.
To sum up,
motivating.
the Orion Nebula is an incredible object that it is easy to observe, educational and inspiring for students. That is why I strongly believe it should be included in the NASE catalog. Thank you for listening. And I would like to thank the entire NASE team for the trust and interest they have shown in us. Thank you, Rosa.
Thank you, perfect. I would like to ask, what about the quality of the sky in Togo? Do you have light pollution?
No, our sky is perfect. We have no pollution of the sky here.
Bravo. Congratulations. Okay.
Currently, Orion Nebula is perfect to see currently in the night sky in Togo. That is very incredible to see it.
Okay. Well, I would like to invite to Ivo, Fatih, or Ligia.
Yeah. The Pleiades, a link between childhood astronomy and traditions. According to my experience, the first stars I ever learned to recognize in the night sky were the Pleiades. I clearly remember that childhood night, standing beside my father when he gently pointed them out to me and said, "Look, those are the 7 little dots." Since then, they have not only become my point of reference for navigating to the night sky, but also cherished a symbol of connection between curiosity, science, and family memory. The Pleiades the brilliant clusters in the constellation of Taurus hold something deeply special, not only because they're easily visible to the naked eye, but because they have accompanied humanity since ancient times, inspiring science, myth, agriculture, and navigation. Their visibility is remarkable. They can be seen easily from mid and high latitudes, which means they're observable from nearly every corner of the planet, except the most extreme polar regions. Their characteristics brightness allows them to be identified without the need for telescopes, making them one of the most accessible and fascinating star cluster for sky watchers. From scientists' perspective, the Pleiades are a chunk open cluster about 100 million years old. This makes them an ideal natural laboratory for studying the early stages of stellar evolution. They have also played a key role in refining the methods used to measure distances in the universe. But their story goes far beyond science. Civilizations across the world have seen them as more than just points of light. In Greek mythology, there were daughters of Atlas. In Japan, there are now Subaru. In Oceania, they guide the Cypheris. And the America, from the Maya to the Inca, including many Mesoamerican peoples, they mark agricultural and ritual cycles. Here in Nicaragua, they are popular known as las siete cabritas, the seven little goats. Our grandparents would show them to us on clear nights, telling stories that wove together mythology and ancestral wisdom. Though written records are scarce, it is believed that indigenous peoples like the Chorotega and Nicaragua observe their helical rise to signal to a start of plantings to anticipate the coming of the rains. And the most beautiful part is that despite increasing light pollutions, the Pleiades remain visible and from urban areas. This makes them a perfect gateway into astronomy education. Many future astronomers, perhaps some for us here today, began their journey simply by looking up and marveling at the small cluster of stars. So between science and traditions, between childhood and deep sky, the Pleiades endure. They are guiding us. Thank you.
Thank you, Ligia. I agree that Pleiades is a very, very special object and also have many cultural presence in different cultures, in different countries. And also it is possible to observe from many, many places because it's not so very far away from the equator. That means that it is a good object for all the world. Thank you very much. And I would like to give the opportunity to give us their opinion to Ivo and Fateme.
I'm ready.
Okay, Fateme.
Okay, hello everyone. I am Fatema Shemnasa, NASA coordinator in Iran and one of the members of Sagheb astronomy community in Iran, which is one of the oldest astronomy community in Iran. I'm delighted to see all of you here and happy NASA anniversary. In this short talk, I want to share you a few thoughts why Hercules cluster should be included in the NASA catalog. As we know, M13 or Hercules cluster is one of the famous objects between astronomers. But what makes this so specific and proper for NASE catalog? Actually, based on our last experience, as you may know, Iran is a very large, vast country. We have a different climate. We have a big city, a small city, light pollution problem, village and remote places. So we decided how we organize this special challenges, a special project. Because of this, in some case, we need to have a online session. We prepare online session for our students and for teachers, and make familiar them with different objects that they can, especially for a student, they can observe in the sky without any help, without any telescope. And among them, one of them was M13. The main reason for choosing the M13 was that it is easy to find. Not itself easy to find, but its constellation is easy to find for a student, and they can easily find this constellation in their skies. So they can easily find the constellation, and after that they can find this bright constellation in the sky. So it would be a very good object to observe. Another that we use this object to explain a lot of astronomical concepts. For example, if we are standing in the yard of our school, always students saw a star one by one of them here, one of them there. But when we show them, this is a global cluster. This is a family of a star. There are thousands and thousands of stars. They are grouped in each other by the gravity. It was very interesting for our student. Before that, most of the time, they think, okay, the stars live alone. They don't have any family member. But when they saw that global cluster, it was very interesting for them, and they could consider this star as a family, as a city. And we use this concept to explain a lot of interesting astronomical aspects. For example, we explain that this cluster could be a time machine. For example, our universe, this cluster is formed near 10 billion years ago. However, our sun and our earth are formed near 4 or 5 billion years ago. It was very interesting for our student to saw some object which is older than our earth, our planet, our sun. So by this we could explain, for example, how the star form, how the galaxy form, how the universe form, and explain a lot of concepts such as stellar evaluation to them. Another thing it was that when they saw the global of a star, they are attached together, they are near together. We explain, think about this. Maybe one of them has a planet. Maybe one day we could find the exoplanet around one of these stars. And this is inspire their curiosity and make them in love more in astronomy, because they can understand, okay, maybe other stars have a exoplanet, have other planets such as our Earth, and maybe one time in future we could find life in such a planet. Another thing was that about M13, it was we could use this special object to explain about the history of astronomy. For example, we know the first one who saw this special global cluster was Edmond Halley. And we use this concept to explain about the history of astronomy and explain some things Edmond Halley did or other astronomy did. And it was a good choice because we could explain a lot of things about astronomy, about history of astronomy, about the evaluation of a star just by one object. And it was very interesting for our students. So the next time when you are in the night sky, you can see this. For example, it was my sentence. When you saw the M13, you are looking one of the crowded place and oldest place in the sky. and it was very interesting for our students. Okay, and because of all of this, I think M13 was one of the best choice for this catalog. Thank you very much, Rosa, and all NASE participants.
Thank you for your comments. I think they are very interesting for all of us, and I agree that it is absolutely necessary to have this kind of catalog. Very simple, very easy, only 16 objects. And the idea is that all the schools can observe them, all of them, because 16 is not a lot. In one course, they can do it. Okay, then I would like to give the opportunity to Ivo to give us his opinion. You can see that each one that presented one object from the different 4 kind of objects that we have in the catalog. And Ivo, of course, have a galaxy, no? I think.
Hello, the great NASE community from all the world, and happy anniversary. Let me introduce myself. I'm Ivo Jokin. I'm NASE coordinator for Bulgaria. So we presented this project, Messier Marathon, during the National Astro Party, which I organized more than 20 years with students and teachers from all the country. So the students and teachers from Bulgaria who participate in this NASE project, most of them patent or conducted visual observation of the Andromeda galaxy. From my observation, I came to the conclusion that children seem to particularly like this galaxy. It is one of the closest galaxy to use. It can be observed even with the naked eye and clear and moonless night. In addition, in various images and photos from different telescopes, it is very beautiful. Of course, after a few billion years, maybe 4, the Andromeda galaxy will collide with our Milky Way galaxy, and they will again separate in the gravitational dance, so that we also have a common future with Andromeda. So generally, students like this galaxy, and that's we believe to be in this great catalog. Thank you, Rosa.
Thank you very much. I think that also a galaxy is necessary for this catalog, and Andromeda is very simple in some way in order to observe with not telescope, because our plan, it was a catalog for schools that don't have a telescope, okay? Then I think that maybe some of the people that is participating in this connection, they can make some comments or some suggestions, and I don't know. I invite to, at the beginning, we invite one person for each one continent, but of course it is open to all the members here that they can add some comments, suggestions. I don't know. Nobody want to add something?
Two words?
Yeah, yes, of course, Magda, please.
I have a small conclusion. If all teachers were like today's participants, astronomy would be very successful in school. Congratulations, Rosa and Beatriz, for everything you do for the success of NASE.
Thank you, but thank you for your comments, for your work, for Beatriz and for me. But I think it's a success for all the members of NASE, not only 2 people.
Okay, but you are the first ones.
More than 1,000 members. And this is a lot of people. We have a lot of people now connected with us. And during all the session, we have more or less 40 participants from the beginning to now. And I think it is a good show proof that there is interest from the participants and from the members of NASE. But Jibashi and yeah.
Hello, hello,
Yes,
Rosa
Jibashi,
and
yeah.
Beatriz and all the rest of the participants. Congratulations for all these years of very hard work. I came to know about this only over the past maybe 5-10 years when I've been trying to get Rosa to help us, and we've been able to be quite successful in running at least one course with Rosa directly present, and then a few courses ourselves. So for me, I think among the galaxies, you know, the Nebula M42 in Orion is the easiest to show to people here in Tanzania. Orion appears as a kind of a rectangle or a trapezium with the 3 stars, the belt stars, and then across the belt in the middle, you can easily point out the area where even without a telescope, somebody can see a kind of a cloudy patch. So I feel that the Orion Nebula, and if you have a telescope, you can definitely make out the cloudy patch, and if the better telescope, you can make out the shape also. So for me, I think M42 is a very good object to show people to get interest in astronomy. Thank you. Okay, that's all. Yeah.
I was not voiced. Dorothy, it's your time.
Hi, everyone. I'm Durruti Jesus de Alba Martinez from Guadalajara, Mexico. I work at Instituto de Astronomía y Meteorología from Universidad de Guadalajara. The object that is historically remarkable here in Mexico is Venus. Why Venus? Because transits of Venus was so important from ancient cultures like Mayans that calculate even 2012 transit of Venus. And in modern era, transit of Venus was in 19th century was the motive to develop of modern astronomy. 1874 was the successful expedition from Mexican Commission to Japan, and 1882 transit was observed in Guadalajara, Mexico, and also was reported. Then we consider that from our country, the object, the planet Venus is historically important for us in this sense, both ancient culture with Mayans and modern astronomy with the Mexican Commission and the persons that established the first modern observatory in our city, Guadalajara. Thank you, Rosa, Beatriz, for all your support and this walking along us. And thank you for all. Congratulations for this quite important effort.
Thank you very much for your comments. We are, of course, interested to continue with this task. And all of you are absolutely very important for us. And well, the suggestion of the NASE catalog was that we thought that it was important to give a list of objects to the teachers, because normally they don't have any special knowledge in astronomy, that they can observe without any special device, without a telescope, okay? This was all to give this information, to explain a little bit some curiosities that could be motivating for students. And this is all. This is essentially our point of view and our idea when we suggest to organize this catalog, because we discovered that really people need to have this small support to give a short list, because it is a very long list. It's impossible that they do it, but only some objects. Maybe it's not necessary all of them. There are 16, maybe they can observe only 8, I don't know. But the idea is that they observe several different kind of objects. This is enough. And to explain a little bit what was the content, okay? Yes, Beatriz.
Can I say something?
Yes, of course.
Just a comment. I remember when at the beginning of NASE, we offer the book 14 Steps to the Universe in the paper format. Perhaps for the NASE catalog, we can produce also versions on paper, and each country and each member in NASE can think how to produce these copies in paper, and offer us gifts or prizes for contest to the teachers or the students, this book, which is very nice. I found it very, very imaginative and very, very nice in the production, in the confection. The cover and the content are very interesting things related in the and tailored in the book. And perhaps it's time also to have more analogical things, and offer the book to be part of the libraries, and to spread the word beyond the virtuality and the digital formats, which are good. But you know, when you have a book on your hands, it's not the same thing. The book has a soul. A book is a special object. It's a technological product, but it's a special object. And I propose think how to have the versions on papers in each country translated in more languages. We have not the power to translate everything to all the languages, and to use this as a kind of presentation card of NASE in these times, in this epoch in which all the people is just connected through the phones and internet. The books need to be live, and we can offer some kind of special books to make better our life. So thank you, Rosa, for permitting me to say these things.
No, I absolutely agree with you. I am also a person that need to have something in the hands in order to catch much better the information. Okay, well, I have to mention that we have difficulties with connection with the last speaker, Julieta Fierro. She cannot participate in this moment because it's impossible to connect. We try I am try to send for WhatsApps and all of this, but it is not possible. Then in any case, I think that it was a success, the session. I am very happy with all of these contributions. I think it is very interesting that we have a result of the last year project, and maybe, I don't know, maybe this year we decide also to prepare something after the project. Thank you very much for your participation. Thank you to everybody for to prepare the activities and the presentations, and thank you to all the people for participating in this session. I am very, very happy that we have an important number of people, because I know that we changed, because the people at the beginning was more from Asia, and now at the end is more for America, no? But this is normal because, well, the timetable is changing, you know, this is astronomy. And then, of course, we have this situation. And, well, in any case, I think that we have an average of 50 people. and it is very, very positive. Thank you very much to everybody. I don't know if Beatriz want to mention something more. Another person, Ricardo.
No, just to say happy birthday.
Happy birthday.
Happy birthday, NASE.
You.
Thank you very much, all the volunteers and the people.
And I would like to insist, NASE are all the people involved in NASE. More than 1,000 people in all the world, in more than 75 countries. Okay?
That's right.
That's right. You are NASE, and thank you very much. And well, we continue. Thank you. Bye-bye. Bye-bye to everyone.
Bye-bye.
If you open your videos, I take another photo saying bye-bye. All of you. Okay.
Bye-bye.
Bye-bye. Bye-bye to all the people.
Bye-bye. Thank you. Thank you very much, everyone.
I took several photos.
Have a nice day, night, afternoon.
Happy birthday to you. Bye-bye. Thank you.
Thank you, guys. Rosa, we need a cake.
Thank you.
You should
Have a
send
nice
it
day.
to each country.
I'm sorry, but I am very bad in this. I cannot prepare a cake. I am sorry.
Well,
maybe Beatriz, I don't know, but Rosa,
Rosa, send the recipe and we can make a cake for NASA's
Monica,
birthday,
hello.
and we'll send you the photos.
Oh, yes, really?
Please,
Wow.
please.
Yes, thank
Please,
you.
please.
Dina. Hello, Dina. Well, very nice. I am.
Well,
Well,
it's Lina, it's Monica.
I promise you that
Bye.
Ricardo is not very good with this, but she has a brother, a sister that prepare an excellent the cakes and this and similar things. And well, next time, Ricardo, maybe can you help us in this way? Thank you to everybody.
Dina
Bye-bye.
and I in Greece will make a cake and send.
That's for sure. Happy anniversary.
See you.
Okay, then
Bye-bye.
Happy birthday.
Happy birthday, Monica. Happy
you
birthday to everybody. Bye-bye.
Bye-bye.
Bye-bye. Okay.
Ricardo, solo cerrar la sesión y ya se corta el YouTube. Después lo edito.
¿Puedes cerrar, Ricardo?
Estás silenciado.
Sí, lo sé. Pero es Beatriz la anfitriona, ¿eh? Beatriz,
No. Vos ahora sos el host.
Vale.
La
Bueno, pues nada,
sesión
yo
corta la transmisión por YouTube.
Gracias, Ricardo, y gracias, Beatriz.
Muchas gracias. Hasta